16 billion miles away, there is no light, no sound, only a freezing void that sits just above absolute zero, a place where nothing moves unless it's already been moving for decades. And in that darkness, something is starting to fail. On February 27th, 2026, a signal reached NASA's Deep Space Network. It had been travelling for nearly 23 hours. By the time it arrived, whatever caused it had already happened almost a full day earlier. It should have been routine. A simple health check. Binary code confirming that Voyager 1 was still alive. Instead, it made no sense. The data was scrambled, not just weak or distorted, wrong. Patterns that shouldn't exist. Numbers that didn't line up. Engineers didn't see a failing signal. They saw something worse. They called it a ghost signal. Voyager 1 wasn't communicating properly anymore. Its onboard computer, the flight data subsystem, the part responsible for packaging everything before transmission, had started to break down. Not gradually, not predictably, instantly. Voyager 1 was never designed for this. It launched in 1977, at a time when computers had less power than a modern car key. It wasn't meant to last decades. It wasn't meant to leave the solar system. It was supposed to pass Jupiter, then Saturn, send back images, and die. But it didn't. It kept going, past the gas giants, past the Kuiper Belt, past the invisible boundary where the sun's influence fades into interstellar space. In 2012, Voyager 1 crossed the heliopause, the edge of the solar system. It became the first human-made object to enter the space between stars. Since then, it has been alone. No sunlight strong enough to power solar panels, no nearby planets, no second chances. Just a small antenna, locked precisely onto Earth, because that alignment is everything. If Voyager turns even slightly away from Earth, the signal disappears. And at that distance, there is no way to turn it back. Voyager 1 isn't failing all at once. It's fading. Its power comes from radioactive decay. Inside the spacecraft, plutonium slowly breaks down, releasing heat. That heat is converted into electricity, but decay is permanent. Every year, Voyager loses power, a few watts at a time. On Earth, that's nothing. Out there, it's everything. 4 watts can mean the difference between keeping a system alive or shutting it down forever. NASA has been forced into a slow, calculated sacrifice. One instrument turned off, then another. Systems that once measured cosmic radiation, magnetic fields, interstellar particles, gone, not broken, chosen, because there isn't enough power to keep everything running. Right now, Voyager 1 is operating on the absolute minimum. Only a handful of systems remain active. The rest have been shut down to preserve what little energy is left. And even that isn't enough anymore. The spacecraft is getting colder. Its internal heaters are struggling. The margin for error is disappearing. So NASA made a decision, not a safe one, not a guaranteed one, a last move. Inside Mission Control, engineers refer to it as the Big Bang. It's not an explosion. It's a full system reconfiguration. They're going to shut down multiple systems simultaneously, reroute power across the spacecraft, and force Voyager into a new lower energy state, all in a single command sequence. No step-by-step adjustments, no real-time corrections, just one transmission sent across billions of miles. And once it's sent, that's it. It takes nearly a full day for the command to reach Voyager, then another full day for a response to come back. For almost 48 hours, NASA won't know what happened. Think about that. You send a command to a machine that is older than the internet, sitting in complete darkness, and you wait 2 days to find out if it survived. Voyager 1 wasn't built for this kind of operation. Its systems have been running continuously for nearly 50 years. No shutdown, no restart, no major reconfiguration. Now NASA is forcing it to do something completely unnatural, and there's almost no room for error. The hardware is aging, memory systems are fragile. A single bit flip, caused by high energy radiation, has already disrupted its ability to communicate. Now they're asking the spacecraft to handle a complex sequence of changes all at once. If one command executes incorrectly, the system could crash. If power is misrouted, critical components could shut down permanently. And if the guidance system is affected, even slightly, the antenna could drift off target. At that distance, even a tiny misalignment is enough to break contact forever. There is no backup system waiting to take over. There is no way to send a corrective command in real time. Whatever happens, happens alone. But the most dangerous part of this isn't the computer, it's the fuel. Voyager uses small hydrazine thrusters to keep itself pointed at Earth. Without them, it can't maintain alignment. Without alignment, communication is impossible. Those thrusters rely on liquid fuel moving through narrow lines, and those lines must stay warm. If temperatures drop too low, even briefly, the hydrazine can freeze, and when it freezes, it expands. Metal doesn't flex out there, it cracks. If those lines rupture, the thrusters fail. If the thrusters fail, Voyager can no longer correct its orientation. It begins to drift, slowly at first, then uncontrollably. The antenna moves off target. The signal weakens, flickers, then disappears. And we won't see it happen in real time. We'll find out nearly a full day later, when nothing comes back. If Voyager 1 goes silent, there is no recovery. No backup probe in interstellar space. No replacement mission ready to take its place. We lose our only direct connection to the environment beyond the solar system. Every piece of data being sent back right now ends. And Voyager itself? It doesn't stop. It keeps moving, drifting deeper into the galaxy, carrying something with it. The golden record, a collection of sounds and images from Earth, voices, music, greetings in dozens of languages, a message, not meant for us, but for anything that might find it. If contact is lost, Voyager 1 becomes something else. Not a spacecraft, not a mission, a silent artifact, travelling through interstellar space for thousands of years. Right now, Voyager 1 is still alive, still transmitting a faint signal, travelling across billions of miles of empty space. NASA knows what's at stake. They know this operation could end everything. But doing nothing guarantees the same outcome. So they send the command and then they wait. And on Earth, we listen for a signal, any signal, because this might be the final transmission we ever receive from Voyager 1.